Thanks for coming. The session today, okay, it shows. Okay, the session today is about how Adobe delivers highly available architecture, highly available applications on Azure through multi-zones, multi-regions, multi-everything. When we thought about sessions for this Ignite, we were thinking about which customer actually implements all the various possibilities, all the various options of high availability on Azure, which could be useful also for other customers, and definitely Adobe implements a lot of great examples. So this session, we are going to go over those examples, and hopefully this will demonstrate how to achieve high availability, best possible configuration, best possible architecture for the complex world-scale applications on Azure. And no. Sorry, technical difficulty. Hopefully it works. And with me today, Kevin. Kevin is a principal PM in Adobe. Kevin is in fact the glue between Adobe and Microsoft, and Kevin is the person that's making those two large machines to work together in unison. Kevin, thank you for joining us. And Dave. Dave actually worked in Microsoft in the past and now is working for Adobe as a senior cloud architect. Dave played a key role in identifying the right solutions that can actually work for Adobe, not just the architectural ideas, but the actual solutions that can be feasible, that can be implemented. So the question is not only what can work, but what actually can work with the right amount of effort. So thank you for joining us, Kevin. Cool. I'll make a really quick introduction, and then we'll jump into the configuration examples, into the application examples. When we are thinking about configuration resiliency on Azure, we think about maybe 4 different steps. The first step is basic VM. When we are thinking about basic VM, what comes to mind is just a VM that doesn't have any resiliency. If the underlying infrastructure goes down, it is down. We are doing whatever we can to make sure that VMs never go down. We try to predict the downtime. We live migrate the VMs in case we can predict the downtime to avoid failure. We are putting the hardware that has the right availability. But nevertheless, unfortunately, failures happen and single VM can go down. Even for maintenance, when you decide to upgrade your OS in that VM can go down. We are offering SLA. We are the only cloud that offers SLA of 99.9, even for a single VM, when it is used with premium storage. But of course, this is a low bar. This is just a start. Many legacy applications are implementing a single VM. But if you are really building a world-scale application, you probably need more. In that case, you might consider availability sets or VM scale sets. Those allow you to spread VMs within a certain data center. So we will make sure that same resources are not used by the VMs inside this scale set or availability set. For example, we will make sure that we use different power feeds, different switches, different top-of-rack switches, different cooling, different fans, different racks, and things like that. But nevertheless, we are still talking about same data center. And if there is a failure that is impacting an entire data center, this might not be enough. We are offering SLA of 99.95 for those VMs. Actually, maybe it's the right time to step back and say that, you know what, those are pretty low numbers. In fact, we are measuring much higher numbers across production. We are measuring numbers which are just different scale from the numbers here. But nevertheless, if you are designing an application, if you are looking for SLA, this is probably the right design point. The latest support that we added in Azure is availability zones. And we are offering 4 nines SLAs for availability zones. So those applications can use VMs which are deployed across multiple zones, or maybe those are deployed as a scale set that spans multiple zones. This provides protection across entire data center failure. Even if entire data center went down, you are still protected, as your application might continue taking the customer queries, customer load in another data center. And of course, one unique aspect of Azure is the global scale. We have more than 50 regions today. Regions are at least 100 miles apart. This means that even in case of earthquake or some other disasters, I don't know, we can think about the disasters, but you are protected even in those cases. This is also useful for distributing the data and making sure that your data resides within the right jurisdiction. And so when choosing how your application works, you might consider using different regions in order to ensure that even if there is some major flood, major earthquake occurs, your application continues running. And so this is a high-level description of various levels of resiliency, but the real question that you're probably asking yourself is, what do I do with those? How do I architect my application to use those various options, and how do I make sure that my customers are successful, or that my application is successful within Azure environment? And from that perspective, we would like to propose considering what Adobe did. And let me just pass the mic to Adobe, to Kevin. Thank you, Kevin.
All right, thank you, Agal. Okay. So let me give, I better not put that down or I will forget it. Just by way of setting context, a little bit about Adobe. We've been in market for 36 years, and we've been involved in a lot of technology and evolution over that time. I would dare say that probably everybody in this room has used Adobe technology at some point, and feel pretty confident about doing that. Business has been good. We've grown to $9 billion in our fiscal year 2018, and we now have about 22,000 employees across the world. We're a technology company. That's what we do. We have about 4,500 patents that have been received from our efforts, and it's just the technology is fundamentally that's the thing that we really are about. So as far as the technology that we use, Adobe is primarily an open source technology company. And so if you look at the technology categories in the left column and you look at what Adobe uses in those, you can see that open source is a big part of what we do across the board. And that comes down and has big implications as far as the cloud providers that we use. We have Space and use 3. We have our own cloud that we provide through our own data center. And then we have investments in Microsoft Azure and AWS, and they are consequential. As far as Azure goes, our investment here, to kind of give a representation of that, this graphic represents a number of the services that are available from Microsoft Azure. And if we were to say how many of those does Adobe not use, and just take those out, you can see that we lose about 10, 15 as far as the things that we don't use out of that entire scope. But the rest of it does have some use and is being used to some level within Adobe. So the scope of our engagement and use of Azure is quite broad. The scale of our use of Azure, some metrics around that, the number of subscriptions that we have to use in order to manage the footprint that we have is in the thousands. We make over 1 billion ARM requests every month in order to manage that infrastructure. And we use hundreds of thousands of compute and database time every day in terms of providing the services that we do to our customers. As far as storage goes, it continues to grow. We are building multi-petabytes worth of data that we have to manage for our customers and do it well, performant, and at very big scale. Kind of give an example of the environment that we work in. This is an example of some extreme scale that we have to deal with from our customer's perspective. things going along pretty normally, and then some big event happens, whatever that event might be, and the incoming data traffic that comes into Adobe that we're collecting for our customers spikes just immediately, almost vertically. And it ramps way up, and then our infrastructure has to scale to support that. And then we have to continue to take that scale and use it over time, or apply it over time as it tapers off, so that we can collect all the data that our customers are sending us. That's their lifeblood, that's our lifeblood. We have to support them and give them the experience, and because of that, we also expect that the vendors that we work with are going to do the same thing for us. So that's context. What we're going to cover today, we're going to basically 3 sections. We're going to start with some research considerations, and then move on to some design considerations, and then we're going to really get into the use cases that Adobe has, where we're using multiple AZs and multi-regions in order to provide the availability for our customers that we have to. So Dave.
Okay. Can you guys hear me all right? Okay. So as Kevin, we picked 3 particular use cases because they show the variety in terms of the different requirements and how we have to design those differently, all using availability zones or multiple regions, but they have different requirements, so we have slightly different designs, okay? So let's take just a minute and cover things that we wished we'd have known when we kind of started on this journey towards deploying very resilient and high-scale applications in Azure. And hopefully some of those learnings that we would have wanted to tell ourselves a year or 2 ago are helpful to you today. By show of hands, how many of you are currently building or have built and are running multi-AZ based solutions in Azure? Okay, thank you. All right, so one of the first things that we would say you want to do is establish a hosting plan. What does that mean? That means identify what locations you want to deliver your solutions from, or Azure regions, and what services your solutions will need to consume from Azure. And then do some research. This is your homework assignments, okay? The first thing is, and this will influence the locations that you're hosting your solutions from as well, is check to see the availability of the services that you're going to be dependent upon to deliver your solution in Azure, okay? There's a great URL reference there at the bottom where you can get most of that data very quickly. And if you have additional questions, visit with your account, your Microsoft representative to get any additional information you need. Second, check to see if the regions that you're targeting support availability zones. Not all regions support availability zones today. You can see in the table there, we've got it set in the first column, the geographies or data residency boundaries. And then in the other 2 columns, the column in blue represents the regions that currently support availability zones, and the white are the ones that don't support availability zones today. And you can see when you look at the paired region strategy that Microsoft has for these data residency boundaries, where you pair one region that has AZs with another region that does not have AZs, there may be use cases where you need AZs in both. And so you want to take that into consideration where that may not quite match with the current strategy that Microsoft has. We've got a use case, Adobe Experience Manager, that Kevin will cover that shows a scenario where we have to have AZs in both locations. So do that research and that homework so you know what you need to do up front, and have conversations with Microsoft representatives if you have additional questions. Highly recommend some of that research. So the last thing to research is, of those services that you're dependent upon, do they currently support availability zones? And if not, and maybe check to see what the roadmap is for those, so that you're aware of these kinds of things right up front, because they will influence the decisions you make and the designs you put in place, or when you can actually implement those designs. So all of that kind of stuff can feed into a hosting plan that can help you determine what regions are the best regions for you, and I recommend having that conversation with your Microsoft representative as well. They may have some additional guidance, but that's critical to get right and get right up front. So that's the homework, some of the research. Okay, now this is kind of a no-brainer, but I want to make sure that we've covered this. So even before you look at things like availability zones to increase your resiliency to address things like physical failures in a data center, even before that, you want to make sure you cover higher priority things that deliver the maybe higher priority or more frequent incidents that you deal with, just common incidents. Make sure you've got monitoring in place, incident response, testing and release procedures. Those things provide much bigger dividends because those kind of things happen much more frequently than an AZ failure. An AZ failure is not a common thing at all. Those kind of things happen to some extent close, but that is not near as common as, say, a configuration error that somebody deploys, okay? So make sure you work through those things first. And we're just assuming in this conversation today that those things are already taken care of or being addressed either ahead of time or in parallel with work that you're doing to design and implement solutions using multiple AZs within a region. And then after you've gotten good at that or in parallel, you can start looking at doing things across regions. Okay, so Adobe, we kind of establish a priority that we work through, make sure that we're taking care of first things first to get the benefits, which is a good experience for our customers. Okay, next one. This one's a little hard to talk to, but what we found at Adobe is that it's helpful for us to refer to this table when we are architecting a solution and using availability zones, and we need to kind of think through availability, cost, and latency, because these have trade-offs. At least in a lot of cases, they have trade-offs. And so understanding the needs of the current workload that you might be working with and reviewing these trade-offs is helpful. For example, as you're working to increase your availability of a solution, now and you incorporate availability zones, the costs can go up as you start to consider things like data transfer costs between availability zones, or maybe additional resources to spread things across availability zones, or potentially, let's say, for example, Azure storage. Let's say you move from locally redundant storage, which writes all the writes to replicas in one data center or essentially one zone, and you're moving to zone redundant storage, which writes to 3 separate replicas in 3 different zones synchronously, and then has to get an ACK back that those writes have occurred to all 3 zones before it can give the application an acknowledgement that that write has occurred. Reads can still happen to the local replica, so they don't change in latency, but writes can change in latency. So you want to be aware. Not saying it's a problem, I'm saying make sure that you're considering it, designing it, and testing for it so you know that it's meeting your requirements. So those are helpful things for us. And then we kind of consider, okay, what do we need? And Kevin's going to talk through the Adobe Experience Manager solution. You'll notice that we actually have multi-region and an actual SKU that we sell that's a multi-region configuration, another one that's inter-zone or multi-AZ, and another one that's non-AZ. And they have different price points because it all depends upon what the customer is looking for, and because those costs can be different, then we actually provide that as actual different solution. So we find that helpful to kind of walk through that to make sure we design according to what the requirements are. Okay, last thing. Understand zonal versus zone redundant. What does that mean? Well, zonal means I'm taking the resources and I'm pinning them to a specific zone. Why is that helpful? Well, you have scenarios where you want to know that all the resources, the set of resources, are aligned with the health of that particular zone. So you know exactly what's going to happen if you lose a zone. There's benefit in that. And then another scenario is, and I'll show you this in one of the use cases, I may need to take a specific VM or a specific resource and apply a specific configuration like a static IP and make sure I've got one of those in a specific zone. And that's a use case where zonal is the approach that works best. So what about zone redundant? That means I'm letting Microsoft distribute those resources for me or replicate those across the availability zones. When is that beneficial? Well, for starters, it's easy, it's simple, and it's usually the default configuration. If you think about things like the standard load balancer, it uses Anycast to take a single IP and represent all the resources across all the zones that are behind that load balancer as that single IP. So if I have a consuming application and I'm taking my service and I'm moving it from non-availability zone to supporting availability zones, I still just have that single IP, so the application doesn't have to change at all. So those are significant benefits of using the zone redundant approach. Another case is just efficient use of resources. Rather than managing 3 small pools of, say, VMs or VM scale sets, I can have a much larger VM scale set that is more efficient in terms of resource utilization spread across those AZs, okay? So those are some of the things to kind of do research around, as well as a few of the design considerations. There's more, but given the time frame that we have today, those are a few things to consider. Now I'll turn it back to Kevin for a minute, and he's going to go through the Adobe Experience Manager use case, and then I'll come back and talk about the other 2 use cases and wrap up.
All right, thanks, Dave. So Experience Manager. A little bit of context about what Experience Manager is. It's Adobe's enterprise class web content asset and forms management software. It's doing well. It does well in the market. Customers like it. The analysts like it. So it's doing quite well there. If you open the hood and look inside, what you have is a 3-tiered application where you have the content authoring side, where the content gets created and uploaded. You have the publisher, where the content is served from disk and scales out and horizontally as we add more of that. And then we have the dispatcher, where it's cached, distributed, and pushed out. So essentially the author as well as the content distribution elements of the solution. As mentioned earlier, open source is definitely something that is a big part of everything that we're doing here. So the operating system that these run on is Linux in all 3 cases. We use Java as far as the technology it's implemented in. So we have the Java runtime, and then for the dispatcher, we have an Apache HTTP server with our own caching module included and installed on that in order to do the dispatching. As Dave mentioned, there's 3 SKUs that we offer as far as Experience Manager, and they are differentiated by the availability. And so the customer can take a look at that and choose the one that makes sense for their solution, what they're trying to do. Single region with no AZs, that's our 99.5 option. Still staying in the single region, but having multiple availability zones, that's our 99.9% availability option. And then if we expand that out to multi-region with multi-AZ, that's where we have the 99.95 option that the customer has a chance to get to. So let's take a look at the second one, the 99.9. Single region, but we have multiple AZs. In each AZ, we put out a publisher dispatcher pair in each one of those zones, and then we front all of that with an application gateway for load balancing and distributing the load across all of the AZs. Some other things that the load balancer does for us, the application gateway does for us, which we really like, is it is the Ssl Offload. So the SSL is all taken care of at that point. And it also provides us URL-based routing, so that based on the request, we can route the requests and the traffic more effectively to the back-end services. But you can see now with this in place, if we have a problem with the application in any particular zone, the application gateway, using health checks and other ways to determine, will determine that that problem is there and reroute the traffic to the other available zones until we get that particular problem resolved and that zone comes back up. Going to the next one, which is our 99.95% availability SKU. Again, now it's the same. We have regions, and they look the same, but we also have multiple regions, each region having multiple AZs. So the key new service in this situation is the traffic manager, which is a global load balancer, DNS-based load balancer, which routes traffic to the different regions based on what's going to service the customer the best. Now, this is not multiple levels of load balancing. The initial request comes to the load balancer sends the IP address back to the region that's going to work for the customer, and then the client makes the requests and talks directly to that region, and the traffic manager is out of the picture at that point. If we have problems, again, then if there's a problem in a particular zone or a particular region, the traffic then can get rerouted by the load balancers to one that's going to service the requests. Okay, some of the things that we've learned in putting this together over the, we've been doing this for a couple years now. So some of the key learnings that we've had is, number one, you have to fail gracefully, and also important, you have to be able to recover gracefully. It's coming back up is just as important as how you handle the going down part, if not more so, because you have to get back up. And so one way to make that better, and that's really important, is that the gateway health checks need to be application aware. If you're just checking to see if it's responding to a ping or a 200 OK or some other surface level check, then you might be getting the responses back saying, hey, I'm here, before the application is really up and ready to respond. And so having more detailed and deep application-aware health checks at the gateway is going to be important. And that's also where you would want to go to your application developer and have them develop the application, design the application with that sort of resiliency in mind. The other thing is the automated recovery. With these kind of SLAs, of course, there's not a lot of time to, automation is your key to success, right? And so you're going to need to make sure that that automation works. You're going to need to test it. Some of the things that we found when we were doing some coordinated AZ down drills with Microsoft, some coordination that we did to be able to do that, we found that when we were doing that with our 99.9 solution, the failover happened really quite quickly because we were able to do it within region at the application gateway. But it takes a little bit more time when we're going from region to region because we have to pay attention to the DNS and TTLS timeouts, which add a little bit of extra time. The most important thing is the testing, making sure that the way you've got your application designed, that the checks you're using to verify whether the service is there and ready to work is going to be key. Okay, next up is Adobe Sign.
Okay, so with Adobe Sign,
Oh, you don't need that.
with Adobe Sign, it's a little different from Adobe Experience Manager. With Adobe Experience Manager, most of what you saw there was zonal. Right? So that's one of the things I wanted to point out is that for that particular use case, zonal was the better pattern for them. And it's a use case where it's a single tenant, right? Each environment is for a single customer. And it's got not only multi-AZ, but multi-region, right? And broken out. So that's one, that has a specific set of requirements, and so it's designed to meet those requirements. Adobe Sign is a little different. So first of all, what is Adobe Sign? Adobe Sign is Adobe's electronic signature solution to replace ink and paper using electronic signatures and some automated workflow. Well, what do we use to deliver that? It essentially, you boil it down to a bunch of VM scale sets that have specific functions and purposes, like web app tiers, or web tiers, app tiers, database tiers, a bunch of them that take care of data conversion, document signing, virus scanning. These are all built into individual VM scale sets. And then there's a number of other Azure services that you can see there, like Key Vault, Azure Blobs, things like that, that we use also to provide this solution, okay? So what does the architecture look like from an availability standpoint? So I'm going to give you a simplified view of it, okay, that you can take away. You take a region with availability zones, put a standard load balancer at the front, and then you build out a VM scale set, and this was a cross-zone VM scale set that has a web for web server, web tier, and then you build another one for the app tier, and another one for the database tier. In this case, we use min and max, which means, hey, here's the minimum number of VMs I want, and here's the maximum number of VMs I want, and keep it at that level, okay? And the database tier as well, then we have 3 of them. And in this case, Azure MySQL is an example of something that's not quite ready. It doesn't have availability zone support yet, so we're using rolling our own with VMs and Tungsten SQL. So tungsten takes care of electing the master and replicating to the slaves or secondaries. And then finally, we've got an Azure Blob Storage tier, and all the VMs will write to that Azure Blob Storage tier according to their individual needs. Okay, so that's the basic architecture, and the flow looks something like this. You have the user connects to the Zone Redundant Load Balancer, which distributes to any of the web servers, which can talk to any of the app servers, which can talk to all the writes go directly to the master, and the reads can go to any of the individual replicas. This gives us the ability to utilize the resource and scale quite a bit horizontally while also providing us the resiliency by distributing those resources across the AZs, okay? So what does it look like from a failure domain standpoint? If I fail, what does that look like? So I'm failing, in this case, zone 3. I just failed my master for the database, right, for the MySQL database. So the first thing is Tungsten has to elect a new master and start replicating to the slaves. And then the Zone Redundant Load Balancer, it does a health check and see, oh, I've got a bunch of VMs that aren't there anymore, so I'm not going to send to those. So the user, when they communicate with the Zone Redundant Load Balancer, they'll talk to the remaining web servers, which can talk to the remaining app servers, which can talk to the new database and do the read and writes to that database, which can continue to talk to the blobs. They can all continue to talk to the blob store, which is creating synchronous writes to the 2 remaining replicas. And then, okay, so what happens, this is one of the takeaways here, one of the learnings is, in the failure, I've got these additional VMs come up. Do those come up automatically? They don't. If I use min and max, that doesn't happen automatically, so what do I need to do? This is something that came out in the testing. So you have 2 options. You can either oversubscribe so that when you do lose one of the zones, you still have enough capacity in the remaining 2 zones, or you can use auto-scale rules that can trigger off of things like CPU and memory utilization to scale up and scale down based upon that utilization. So those are your 2 options in terms of dealing with capacity after an event, okay? So let's look at some of the key learnings. I just mentioned the first one about VM scale sets. In the case of Adobe, we noticed in our testing and partnering with Microsoft during some of the down drills that it can take a little while for some of those additional VMs to come up. In the Adobe Sign use case, that wasn't sufficient. So we had to go with the over-provisioning scenario to make sure we have enough resources in zones 1 and 2, if we lose the 3rd, to be able to meet that capacity. It doesn't mean that all use cases are that way, but that one, that's what we had to do. We did notice also, like I said, right now we're rolling our own in terms of MySQL resiliency and working with Microsoft on the timing for when Azure MySQL will support that. And the last thing, when we did down drills, we didn't have any customer impact. So we've actually did, in those down drills with our partner, that was a great result. Lots of kind of learnings, like we said, about how VM scale sets work and things like that. But the end result for the customer experience was what we were looking for. Okay, Adobe Ethos. What is Adobe Ethos? Adobe Ethos is Adobe's CI/CD and compute containerization platform. We use it for both internal workloads and external facing workloads for compute containerization. A key part of what we build our solutions for our customers and our internal needs. It's, for the most part, built on top of Kubernetes, as well as consuming some additional Azure services. So what does that architecturally look like? I've got a subscription with multiple AZs. I put a virtual network in there and a subnet. Important to note, networks and subnets are AZ agnostic. They're not associated with an AZ. The resources that you create, like VMs, IP addresses, things like that, they're associated with the availability zone. So I want to create a Kubernetes cluster inside of that, as part of that subnet. And in this case, I need zonal VMs. These are my etcd VMs. They do the configuration for me. They have to be guaranteed at least one in every availability zone, and the IP address has got to stay the same. It can't change. So zonal is the way you would use that. Now I build on top of that zone redundant VM scale sets. This is where my masters and workers for my Kubernetes cluster reside. And they spread out. We want them to spread as much as possible across the availability zones. And we create 2. Why? because we have run into scenarios where we have an unhealthy VM scale set, or we need to be able to actually replace. Let's say I need to move to a different VM SKU. I need to be able to roll forward. This is part of forward compatibility. So we create two because of, like I said, first of all, most importantly is whether it's an Adobe scenario that's created an unhealthy VM scale set or a Microsoft scenario that created an unhealthy VM scale set, it's another failure domain for us. And so we create two to create some separation there, as well as distributing those across availability zones. Okay? And then we actually deploy the containers across the multiple VM scale sets to be able to deal with that failure domain. Okay, then I have a load balancer in front of that, and that load balancer distributes the load to the containers across the 3 AZs. Okay, to move forward, just simplified failure example. If I lost zone 3, our ethos cluster will spin up additional containers in the remaining availability zones, and then the load gets distributed from the load balancer to those containers in the remaining availability zones. Scaling is the same as with the Adobe Sign example. You either got to over-provision or put in auto-scaling rules to scale up the underlying VMs in the VM scale set. Okay, this is one of the things that this ethos team wanted to make sure I conveyed. There's also another failure domain that you have to keep in mind. There are scenarios where you can run into limits in a given VM scale set. This is relative to your scale, right? If you're a smaller organization or your scales is smaller, then you don't see this as much of a risk. At Adobe scale, as Brian was calling out, we have this as a risk. And so we have to make sure we take into consideration a subscription as another thing that we look at from a scaling size limit, which can have impact on our customer experience. So we take the example we had before, and we put Traffic Manager in front of it to distribute across multiple scale sets, or excuse me, multiple clusters that have multiple scale sets built into them. So we take it a step farther, and then we give guidance to the application teams to deploy across both of those clusters. Okay? Now, a failure in that case, notice I lost a zone, and in one subscription it's zone 1, the other subscription it's zone 3. That's because a zone is a physical thing, but from a subscription standpoint, it's a logical representation. My pointer to zone 1 in subscription, zone 3 in subscription A, and the pointer to zone 1 in subscription B, they're both pointing at the same physical thing, but it's a logical pointer. So you have to account for the fact that that doesn't remain consistent across subscriptions. Okay, and let's say, for example, I also had a VM scale set that got unhealthy during that down drill as well. In a case like that, then my ethos cluster is going to deploy the additional containers in the remaining VM scale sets on the remaining workers, and the load balancers do a health check and distribute the load to what remains there. So that's it in a nutshell. So the learnings from that is, this is one of the things that the team wanted me to make sure you knew, is be forward compatible in your designs. That means make sure all the resources that you create, you can replace those resources. Not just modify them, replace them. That's one of the reasons why you have 2 VM scale sets. We have scenarios where we needed to go from a basic load balancer to a standard load balancer, or we go from the F series VMs SKUs to the DV3 series VM SKUs. Really important. Without that, we would have downtime. And that's what we're trying to avoid. It goes beyond just spreading things across VM scale sets. You can't rename or move. You need to replace. You want to do A/B deployments. All those kind of things come into making sure that you design so every resource can be replaced. And then, as we mentioned, distribute resources across availability zones, as well as across other failure domains, logical failure domains like a VM scale set as well. Design for multiple subscriptions, as we mentioned, as well as the last thing is, when you're creating your infrastructure and your application code, just put lots of on-failure clauses. Right? Those are well worth the time and effort that goes into it to be able to handle the failures. You're going to find new ones, right? And you're going to want to be able to handle those. So those are some of our key learnings. So last bit, takeaways. I'm not going to go, most of these are kind of going back and referring to the things that we've already talked about, but they're kind of summarizing those takeaways. But one thing I want to point out, when you're assessing the resiliency architecture trade-offs, if you go multi-region, for example, like AEM, and you're active-active, then you're doing a good job of balancing cost and availability because you're actually using those resources as you spread them across regions. And so that's a good way of kind of looking at how you can build out a design that will minimize the cost while you're maximizing your availability. And then the last thing down at the bottom is check back often. There's so much changing in this space. Between the conversation or the session we had around this topic last year and this year, so much has changed. So many of the resources support AZs, so many more regions support AZs, so you want to check back often on that. And then lastly is, if you want to kind of go hit some other sessions as well, the breakout session 3129 around building resilient applications in Azure is also a good one to kind of reference as well. So with that, I turn it back to Igal and some Q&A. Hopefully that was a helpful, quick kind of view of where Adobe's at. And
this was amazing, and I think this serves as a great reference for anyone who wants to build a highly available application on Azure. And we have 3-4 more minutes for questions. Please use the mics.
oh no, not Paolo.
Uh-oh.
Hey, Dave. Thanks for the great presentation. I just wanted clarification from Adobe to the rest of the audience here. What is AZ down drill? It seems to be interesting, but I don't know if they got the concept.
Sure. So for example, when the Azure France, let's see, UK South, or let's see, UK Central, or sorry, France Central and France South regions were being built, there was an opportunity for us to partner before they went live. We were able to partner with Microsoft, and actually they're doing a down drill to make sure everything's functioning right, and we were able to deploy, they gave us a chance to deploy our applications in that zone, or in that case, both regions. So we did both an AZ down drill plus a region down drill. So in an AZ down drill, they powered down an AZ. We saw, what was the effect. And then in the region down drill, they powered down all 3 AZs and fell to the other regions. So it was an opportunity in situations like that, yeah. Yeah, there's also some other drills that they do on a somewhat regular basis, but I'll let Igal kind of talk to that.
We have a program that we call Azure Early Update Program. This is essentially what we internally call Canary. We are offering our customers an opportunity to run pre-production bits before they hit our production environment. And one added value is that we are continuously doing availability drills in Canary, at least monthly drill, and you can subscribe to random impairments there as well. And so from the perspective of testing resilience and high availability, this is a great place to use.
Super helpful for us. And Paolo's got inside track here. He's the CSA, lead CSA assigned to Adobe. So when you look at some of these designs, his fingerprints are all over those designs as well. Significant resource, critical resource to Adobe for this work.
Thank you. Before we go to the next question, I do want to show that we do have evaluations for this session, and so please evaluate whether you like this session, whether it's useful. Next question.
Hi there. I'm Philip Glebo. I run architecture at Gap Inc., the clothing brand. I'm curious what your filter is for things that you use in Azure from a security perspective. We struggle with some of the openness of Azure, and I'm just wondering what your no-goes are at Adobe when you evaluate a service.
Yeah, so there's the obvious things in terms of access control, key management, encryption at rest, in transit, and then we do quite a few things to make sure that, I'll give you an example. We have a solution we call Mavlink. Mavlink ingests all activity logs. And then we set up rules looking for things. Anytime we're looking for something new, it just processes those. So think about us ingesting everything coming from Azure, including we go out and actively interrogate using the Azure Resource Manager, the configuration of every resource at intervals, right? At least daily. And that pulls that into a security data warehouse. And then we have a whole set of rules that we process and take actions on, whether they're automated or creating a ticket request to address. That's the foundation and the core part of it that we lean on to start with. And then when we look at each service, we look at things like, I'll give you an example. Service endpoints are critical for us because we're not really comfortable with a public endpoint for some of the data pieces. So We are adopting service endpoints as quickly as we can, and private link, which has kind of been announced, those aspects where we can actually remove that public access and just do private are actually very important too. So we kind of assess it in that framework a little bit. Does that make sense? Does it, or help a little bit with kind of how we?
I think where we struggle with is lack of Active Directory. Ironically enough, integration at Microsoft, a lot of their tools don't support that.
So yeah, let's talk offline a little bit more. We can learn from each other, actually.
Okay, guys, I apologize. We are out of time. We will be available here for another 5-10 minutes to answer any additional questions. Thank you so much for coming, and please don't forget to fill the evaluation. Thank you so much for presenting.